Hi, my name is Dr. Hassan. Today I'm going to introduce my book Data Science Gym. So let's get started. Here is the cover of the book. The book is titled Data Science Gym, and I have written it specifically for those who want to get started in data science. So data science, as we know, is a hot new domain which covers a lot of different things, and it can be difficult to get started in it due to a number of different reasons. So we want to basically have a book which could introduce this subject for undergraduate students for their first course in data science, as well as for those professionals who may want to start data science at some point in their career. So, a lot of different people want to get started in data science. So, it may be doctors, it may be engineers, it may be, electrical engineer, chemical engineer, telecom engineer. Everybody needs to use data science in their work. So, bankers may need to use data science to predict fraud and so on. So, there are lots of different people who are learning data science, and they need a good reference using which they can get started and, gain uh, gain a good depth in the subject with lots of practical skills as well. So this book is for all those guys who want to get started in data science. So as I said, this is an easy to understand book written for people who want to get started in data science with little or no programming background. So you may have some computer knowledge, but you don't need to have lots of programming background in order to get started. So this book basically tries to teach basic concepts, algorithms, but not going into too much detail, processes that you need in order to develop data science applications or solutions, and it basically teaches you about concepts, algorithm, and then, it applies, machine learning and AI algorithms on various simple to understand problems. So one of the challenges for those who want to get started in data science is, uh, you know, uh, there are many other resources which may introduce very complicated problems, involving or requiring lots of different skills, and, a level of expertise and understanding well beyond the novices, or, those who are getting started in it. So what I try to do is basically I try to keep the problem simple, and I try to basically uh, uh, introduce concepts in a way where, you can just learn the essentials and apply them on simple to understand problems, and that would help you get going. And, with passage of time and as you do more things, uh, you can basically become an expert in this domain. Also, what a challenge that new novices, or, those who are getting started, they face is, people quickly introduce a lot of complex concepts or algorithms without introducing lots of different basics. So there are lots of different steps involved in solving a problem, which essentially are being missed in many cases. So one of the key things that this book introduces is it provides collection of essential concepts and hands-on exercises that are actually key part of the process of data science, which you need in order to master data science. So I try to introduce all the key things with simple to understand uh, uh, concepts and simple to understand examples and language, so that you can learn it at your ease and become a master of data science. Okay, so here is an overview. A main goal of this book, as I said earlier, is to teach you the basic concepts, algorithms, but not only concepts and algorithms with their implementation, but also the processes, skills, and along with sharing broader knowledge of data science with the help of hands-on exercises. So data science, learning data science can be very challenging because it relies on lots of different lots of different subject areas and domains. So that's one reason that people can quickly get lost, because an expert from one domain would put a lot more emphasis on their area of interest, and that would make things complicated for a broad range of audience who need a lot of depth in different areas in order to solve problems that they want to solve. So first of all, in order to help uh, give you the basic understanding of the whole subject area, I introduce data science in chapter 1, in which I provide a lot of basic knowledge, concepts, overall an overview, which would help you understand why we are learning different things in this book and in the wider domain of data science. Then Python is the key language. It's probably the leading language uh, for using data science. So right now it's most people use Python for solving data science problems, and this is followed by R. So I use Python for teaching all the examples involved. So I introduce Python essentials for data science. Once again, you can learn basics of Python from any other book or from the resources available on the internet. But then, to learn essentials of Python for data science, you can consult, a lot of examples available in data science. And even during your career or further learning in this book, you can keep referring back to examples in chapter 2 in order to basically uh, gain of good reference and firm hold, firm grip on Python essentials for data science. Data science is basically a data-driven subject. So you have to analyze data, and you have to understand data, and you try to understand the trends and anomalies in the data as part of being data scientist. So this is first thing that you need to do. So you need to be expert at data analysis and visualization, and the goal of chapter 3 is to give you that kind of expertise and that kind of uh, you know uh, skills and that kind of uh, you know uh, to make it to make data analysis and visualization part of your passion, to make you passionate about data analysis and visualization. So that's the goal of chapter 3. So I try to give you all the essential skills for that. Then chapter 4 basically uses your skills in chapter 3, and basically tries to make you a bit more expert in exploring data and processing data. So these chapter 2, 3, and 4, they provide you the basic skills for being a data scientist. So when you are basically an expert in Python, and you can analyze data, and you can see trends in data, you can see anomalies in data, you can see correlation in data. Once you do that, then basically you can go on and start applying various data science techniques such as classification, regression, clustering, decision trees. You can apply all those classification and regression techniques on your data. So basically, to be a data scientist, you have to be a good data analyst, and you have to be good at data visualization, and you should be able to tell stories about the data, what you are seeing in the data, and then you basically should be able to apply various advanced algorithms on the data in order to predict things, or in order to predict trends, and in order to see all the different aspects of data, and to assist in intelligent decision making. Okay, so let's move on. Uh, the next key thing that you need is feature engineering. So we have to basically, many times we have to create new features, we have to understand features, we have to basically see which features are impacting our decision making, and so on. So feature engineering basically helps us in order to improve our features in many different ways. Whenever you build a classifier or classification system or regression system, you need to evaluate its performance as well. That's a key part of being a professional data scientist, that we can accurately judge the performance or evaluate the performance of any classifier or regressor, and then we need to basically optimize various parameters in order to improve our performance. So once we gain this kind of skill set, then we can go on and basically use various other advanced algorithms such as support vector machines. So let's assume that you have got a key set of algorithms that you know, and you can improve, you can understand your data, you can improve your features. Then maybe you are ready to uh, basically launch the system for others to use. So data science systems basically have to integrate with other parts of the system. So other parts of the system may be a web application for driving sales, or it might be uh, a mobile application in which you are giving input to the user. So in order to integrate with all those applications, you might need to build API. So data scientists might build a system that can predict what is going to be the next uh, price for a stock, or whether the transaction is fraudulent or not, things like that. But then uh, you know uh, it has to integrate with other systems where people are actually consuming that information. So in order to buy the stock or sell the stock, they need to have a predicted value of the stock, where it's going, and to basically get predicted value from the system that you have built. You need to give them an API where they give the current value of the stock, and you tell them what is the predicted value of that stock. And if you have done a good prediction, then they can probably make money out of that. So a data scientist, our teams of data scientists often would have to build APIs to expose their models, and that's what we do. So essentially this book gets you started from the very scratch, where we introduce what data science is, what is the process of building a data science system, what are the steps involved in building a data science system. Then we basically introduce Python language, or essentials of Python language specifically for building data science systems. And then we get you on, or we prepare you to analyze the data, to visualize it in appropriate way, so that you can explore the data, you can see the trends in data, you can see correlations in data, you can see anomalies in the data. And once you are very well familiar with the data, you can then basically apply algorithms on that, such as classification algorithm. And Bayesian classification can be a very good algorithm, not only for prediction purpose, but also for understanding the data, understanding the relationship in the data. We introduce regression for predicting values. We introduce clustering for maybe automatic segregation of data, automatic division of data into various classes, and so on. Then we introduce decision trees and forest for classification purpose. We introduce feature engineering, and that would help you to improve your features. And then we go on and introduce how you are going to actually evaluate classifier performance, how can you optimize features in order to improve classifier performance. We introduce support vector machine, which is an advanced classification algorithm. And then finally, assuming that you have built a good enough system that can be used by others in the world or in your organization. Then we introduce how you can build APIs for exposing your data science model using Flask API framework, sorry, Flask framework. So what is data science? This is the first thing that we introduce. So data science is an umbrella term covering the use of various subject areas in a systematic way to solve problems where massive data is available. Okay, so in as compared to machine learning or AI or other fields which are related with data science, um, in data science we are actually using other subject areas or fields to solve problems where data is actually available, and we can learn from the data in order to solve the problem. So in many cases you would use various other domains in order to collect the data. Maybe you will record videos, maybe you would record audios, maybe use x-rays and other methods to collect various types of data. And once the data is available, and maybe expertise is available in order to understand that data, then we convert that data into a form where machines can learn from it, and start doing what experts can do. So here you can see that within data science we use many different domains. So personally, I have used machine learning, I have used supervised machine learning, unsupervised machine learning, deep learning. I have been exposed to natural language processing. I have covered chatbots at some point, and I have been taught translation kind of systems and various basics of NLP. Being a computer scientist, I have worked with structured data, unstructured data, the various systems for storing and retrieving data such as Hadoop, and so on, columnar databases for storing vast amounts of data and crunching numbers, aggregating and so on at a very at very high speeds, and then obviously we have expert systems, we have fields like computer visions which work exclusively on images and try to learn from images, and obviously we have robotics which tries to process information using cameras and various sensors and try to make decisions based on that. So, in order to become data scientist, or a very good data scientist, you would typically start with a background in computer science or some related field, and then you would learn a lot of different things. So you would learn information retrieval, you would learn analytics like we do in our book. So we cover lots of data analysis, visualization, exploratory data analysis. You would be exposed to big data. So companies like Twitter, which process billions of tweets, and there are people who work on tweets related to specific hashtags and try to learn what people are saying about those subject areas. Obviously, you need some programming skills, you need data management skills, so you need to be able to put data into databases and file systems and organize it, and then uh, ingest it and explore it and process it and so on. And obviously at the end of the day you need to produce dashboards and reports, and in various ways you need to communicate what you have learned from that data. So these are all the different things that we try to cover in our book Data Science Gym. So here is, to give you an example, here is the basic process that we have been taught about machine learning. So in machine learning, we tend to follow this basic process. I have covered this process in various classical books like, I don't know the title, but there was a book by Duda and Hart, and they basically give this process, or they introduce this process originally. So we get started with problem definition. So the problem definition might be as simple as, you want to basically differentiate between different types of fish on a conveyor belt. Then you basically acquire data using, let's say, cameras and different sensors. Then you pre-process the data. Maybe during pre-processing, you are separating various objects and you are cleaning the images in order or you are maybe discarding some images where it is not possible to separate objects and so on. So once you have done the pre-processing, then um, on the output of pre-processing, let's say it's images, segmented images of fish, you extract features of the object, like maybe you are interested in color, you are interested in length, you are interested in width of that object. So once you have extracted those features, then you basically apply some algorithms to do the classification, and output of your classification might be something like salmon and sea bass, as shown by Duda and Hart in their book. So this is the kind of process that is applicable to all the different problems that we solve in data science. And this pipeline, we refer to this process as a pipeline as well. In this pipeline, you can apply the similar pipeline on fraud detection problem, on on lots of all the different problems that we tend to solve in data science. So here is a more detailed version of the pipeline that we build in order to solve business problems. So the first part of the pipeline is business understanding. So we want to determine business objectives. For example, in case of Amazon, the business objective might be to drive their sales. So in order to drive their sales, they basically make suggestions to people to buy. If somebody is buying a book, then they would make a suggestion about buying other similar titles that may be liked by similar people, or people buying similar objects. Then you understand the data. So in that phase, you basically collect initial data, you understand individual features of the data, or you extract those features, you explore that data, and then you might also verify data quality. Then you prepare the data in a form which might be suitable for building models. So once you basically have prepared the data for achieving the best possible results during the next phase of modeling, then you apply suitable modeling techniques, and let's say you try two different techniques on the data, and then you evaluate them to judge their performance. So maybe you applied four different techniques, modeling techniques on the data, and then according to the results that you are getting, you do objective analysis on that, and you try to judge the best possible techniques. Once you have built the best possible model using optimization and comparative analysis and evaluation, then basically uh, you might build an API, or you might just deploy the model as a function, and so on. So you basically train the model and then you deploy it, and other people can start using the model that you have built for predictive for predicting the classes, or predicting the values, and so on. So this is the process that we then tend to follow in our book on a lot of different techniques and a lot of different problems, and hopefully by going through all those techniques and problems, at the end you can become a proficient data scientist, and then you can apply the same problem, same approach that you learn, same concepts that you learn in this book on more and more complex problems, and on using more and more complex algorithms as well. So You can get this book from Barnes and Noble. I have given the URL uh, on this slide, as well as you know uh, in the description for this video. So you can also get it from Amazon. You can just Google the title of the book, Data Science Gym, and you can go to one of the links available in your Google search to get the book. So thank you very much for listening. And if you have any questions or anything, then you can ask that in the comments. Thank you very much. God bless you.